Hey guys, this video is about solving components for parallel circuits. Unlike the first parallel video, these problems don't actually give you all the values for the resistors, but you'll have values for voltage and current. I'm going to review two problems. After reviewing the first problem, there is a 5-minute break for you to try out problem number 2 before I walk through how to solve it. Let's get started. In the past, we had a parallel circuit where we knew the resistance in each of the resistors, but in this case, we won't. We'll have two resistors, but we'll only know the resistance in one of them. So we have R1 and R2. And we'll know that R1 has a resistance of 3 ohms, and there's a current of 5 amps going through the circuit. I'm going to move this over to the side so that we can make a table. And again, in this table, we'll have V for voltage. We'll have I for current in units of amps, and we'll also have resistance in units of ohms. And we'll calculate these values again for R1, R2, and for the whole circuit, which we'll just call T. If you look at the circuit diagram, you see that we have a voltage drop of 12, so let's go ahead and put that in. We also know that the resistance in R1 is 3 ohms. We also have this value of 5 amps for current. This is actually the current going through the circuit before it hits the node. And remember, for parallel circuits, this current splits. So all we know at this point is that the total current is 5. Looking at the table, it looks like you can use Ohm's law to find the total resistance. However, make sure to fill out everything you know about circuits before you actually use Ohm's law. Recall that resistors in parallel have the same voltage, and this voltage is actually equal to the total voltage of this circuit because there's nothing else going on. So we have 12 volts for R1 and R2. Now when you look at the table, you can see that you can calculate the current for R1, or you can calculate the total resistance for the whole circuit. I'm going to start with R1 first. At R1, we can use Ohm's law, V equals IR. We know that the voltage never changes, so it's 12. The current is what we're trying to find out, and we know that the resistance is 3 ohms. Divide each side by 3, and you get 4 amps as your current. You could technically use Ohm's law right here, but recall for parallel circuits, the current has to add up to the total current. So 4 plus 1 equals 5. And now I can calculate R2 using Ohm's law. At R2, we have V equals IR. The voltage is 12, current is 1, and we're trying to calculate R2. Divide each side by 1, and you end up getting 12 ohms for R2. You technically can use the parallel resistor equation to calculate the total resistance, but if you hate fractions like I do, you can also just use Ohm's law again to calculate the total resistance. So if we have for our total, V equals IR for the whole circuit, 12 volts is equal to 5 amps times R total. Divide each side by 5. 2.4 is equal to the total resistance. Let's actually use a parallel resistance equation to confirm these values actually work. Recall that 1 over the total resistance is equal to 1 over R1 plus 1 over R2 here. So we have 1 over 2.4 is equal to 1 over 3 plus 1 over 12. Multiply the first term by 4 over 4 so that they have a common denominator of 12. And we have 1 over 2.4 is equal to 4 over 12 plus 1 over 12. So 1 over 2.4 is equal to 5 over 12. Recall that if you leave your answer like this, you actually would get 0 points or partial credit because this is the reciprocal of the total resistance. So remember to flip the fraction on both sides, and then you end up getting 2.4 is equal to 12 over 5. 12 over 5 is actually 2.4, so the equation holds true. I'm going to stop here so you can try problem number 2 solo before we start to review it. Hi, I hope the problem went well. Let's go ahead and review. If you look at the diagram, we're given that there's 10 amps going through the whole circuit. We're also given that resistor 1 has a current of 6 amps. In this problem, instead of giving you the total voltage, we know that there's a voltage drop of 12 volts across resistor 2. Remember to fill out as much as you can in the table before going to Ohm's law. So for parallel resistors, we know that the voltage has to stay the same. So R1 has a voltage drop of 12 volts, and the total voltage for the whole circuit is also 12. Recall that the current in all the resistors has to equal the total current. So we have 6 plus 4 should equal 10. And now looking at the table, you know that you can calculate the resistance in each of the resistors by using Ohm's law. Let's start with resistor 1. At resistor 1, we have V is equal to IR. The voltage never changes, so it's 12 volts is equal to 6 amps times R1. Divide each side by 6, so we have 2 ohms is equal to resistor 1. Let's continue with resistor 2. At resistor 2, we have V is equal to IR. 12 volts never changes. Current is 4 this time, and the resistance, well, we're trying to figure that out. Divide each side by 4, so you have 3 ohms is equal to R2. Technically, you can use the parallel equation to calculate the resistance, but instead I'm going to use Ohm's law again. So for RT, we have V is equal to IR for the total circuit. 12 volts is equal to 10 amps times RT. Divide each side by 10. And we have 1.2 ohms is equal to the total resistance. Let's double check our work by using the parallel resistance equation. We have 1 over RT is equal to 1 over R1 plus 1 over R2. So we have 1 over 1.2 is equal to 1 over 2 plus 1 over 3. The common denominator can be 6. So multiply the first term by 3 over 3 and the second one by 2 over 2. So we have 1.12 is equal to 3 over 6 plus 2 over 6. 1 over 1.2 is equal to 5 over 6. Recall that this is actually the reciprocal, so let's go ahead and flip the fractions. So we have 1.2 over 1 is equal to 6 over 5. 6 over 5 is actually 1.2, so the values do check out. Thank you for watching. I hope you enjoyed this video. Feel free to subscribe and like below.